In this lesson, we're looking at the lead-in to inclusion-exclusion principles. So we'll be focusing on sets, Venn diagrams, and looking at intersections and unions of sets. Okay, so first thing we're going to do is we're going to define a set. So a set is basically a collection of well-defined objects. These objects we generally refer to as elements. And so a set A can be written as set A is, and then within that set we have elements. In this case, it is an empty or a null set. That can also be demonstrated with that symbol. So if we were to say set A includes the elements 1, 2, 3, and 5, then we'll be able to say that A is equal to the set containing 1, 2, 3, and 5. Okay, so pretty straightforward. Essentially what we're saying is that a set is a collection of well-defined objects, elements, and it's very easy to express that mathematically. Now, we can also say 1, 2, 3, and 5 are elements of the set A. So this is telling us that these 4 things are elements of set A. This symbol here means elements. Now, what we're really focused on today is looking at the intersection and union of sets. We'll mostly be using Venn diagrams for this, but we want to define the symbols and the language first. So an intersection is basically elements that exist in more than one set. A union is elements that exist in one or more of the sets. And so the symbol for intersection is that. So this symbol here means intersection, and it in probability terms pretty much means and. So it exists in set A and set B, for example. And then the union is the opposite, looks like a U, and in probability sense it means or. So for example, if we're looking at A or B, then it's A union B. Alright, so to put this all together then, we're going to end up looking at these in Venn diagrams, and we'll use an example to do this. So let's look at our example. It will be, so this is a pretty straightforward example. We've got for a universal set, omega, which includes all the numbers from 1 to 20, set A, which is multiples of 2, and set B, which is multiples of 3. We want to define omega, A, and B. I should have said here that set A and B are subsets of omega. So set A and B are subsets of omega. Now that's pretty important. That means that they can only include the numbers up to 20. Okay, so starting with omega. Omega is pretty straightforward. Omega is a set that includes 1, 2, and all the values up to 20. Now we could write those all out. Obviously it's easier to write it with that ... So that tells us that it includes all the numbers from 1 up to 20 with integer joins. Alright, so set A will then be all the even numbers. So that means we have, so multiples of 2, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Set B will be multiples of 3, so that will be 3, 6, 9, 12, 15, and 18. Okay, so it's pretty easy to define those sets. We're just writing out with our special squiggly brackets the values that fit the conditions that were given. Alright, now the second part is to draw a Venn diagram, and this is a little bit more complex, but still quite easy. So if we're drawing a Venn diagram, what you really need to do is be able to look at all the sections. First of all, we'll consider, is there a crossover? Is there an intersection between A and B? So the set A and B, which values does it include? So what are the values that exist in both? We've got 6, we've got 12, and we've got 18. So set A and B is 6, 12, and 18. So that's very important. We know that there's an intersection. So when we draw set A and set B, they have to have an overlap. Okay, so here's A and here's B. The values that are in the intersection between A and B are 6, 12, and 18. The leftover values that are in A but not in B are 2, 4, 8, 10, 14, 16, and 20. The leftover values are in B but not in A are 3, 9, and 15. Now, the values that are then in A or B, or in A union B, are everything within these two circles. So even the intersection. So A or B will be 2, 3, 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, and 20. Now the values outside will say they're not A and they're not B. So this dash up here means not. And so that's everything that's not. We'll talk about that in a second. And so that means we've got 1 left over, and 5, and 7, and 11, and 13, and 17, and 19. So the values that aren't in there are here. We've got 1, and 5, and 7, and 11, 13, 17, and 19. All right, so now within this Venn diagram, it represents all of the possible values. So from 1 through to 20. Essentially, that's what we're going to do with the Venn diagrams. We're going to represent the whole sample space, looking at what is included in each of the subsets. So in this case, A and B, and then which exists in the set and are outside the subsets or not included in the information given. Now, there's a few other things we can define. So we know what A is. Not A, so this means not A would be everything that's not in A. So if A is 2, 4, 6, 8, 10, so A is our multiples of 2 or even numbers, so not A would be all of the odd numbers, so it would be 1, 3, 5, 7, and all the way up to 19. Not B would be everything that's not a multiple of 3. So not B would be 1, 2, 4, 5, 7, and all the way up to 19 and 20. Now, a nice way to look at this is in this Venn diagram, if this is A, then not A is everything that's not in that circle. And not B would be everything that's not in that B circle. Our A and B is simply just the intersection between the two sets. Our A or B is all of the information within the two circles, within the two sets. And the not A and not B is only what is outside of the two sets. Okay, so there's a couple other things that we can define. We can say A and not B. So these are the things that are in A but not B. So in A but not B, which is our 2, 4, 8, 10, 14, 16, and 20. So that would be this section here that doesn't include the intersection. And if we looked at not A and B, that means we're looking at the ones in B that are not in A. So they are simply 3, 9, and 15. And in terms of space, they'll be the ones that exist in B, but not the intersection. Essentially, that's what we're looking at with our Venn diagrams, our intersections and unions of sets. Finally, when we look at cardinality, cardinality simply means the number of elements in a set. So when we're talking about cardinality, we can either represent it this way. So this means number of elements in A, or we can say n of A, and that means the same thing. Okay, so if we were to say the cardinality of the universal set, it will be 20. So there's 20 elements in that universal set. If we say the cardinality of A, so how many numbers are in A? So we're just looking at those even numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The cardinality of B would just be those multiples of 3, so 1, 2, 3, 4, 5, 6. The cardinality of the union between A and B, so there was 3 values in there, and so on. I'm hoping that this makes relative sense. I'll follow up with a lesson that has a couple of examples and practice problems, and then we'll set some questions for you to do.